The table shows Tom's test results for different subjects. In what subject did Tom get the highest mark? So some of the marks are written as fractions and some as percentages. But to be able to compare, we need to change our fractions into percentages. So in arithmetic, he got 34 out of 40, and a percentage is a fraction with a denominator of 100. Now we can't multiply 40 by a whole number to get 100, so what we need to do here is to simplify first. Both 34 and 40 are in the 2 times table, so we can divide the numerator and denominator by 2. 34 divided by 2 is 17, and 40 divided by 2 is 20. So now that we know that 34 over 40 is the same as 17/20, we can convert that to a percentage by finding an equivalent fraction with a denominator of 100. 20 times 5 is 100, and 17 times 5 is 85, so that's 85%. Now, in reasoning, he got 63 out of 70. Again, we need to simplify first because 100 is not in the 70 times table. If we divide the numerator and denominator by 7, that gives us 9/10, which we can see is the same as 90/100, so 90%. And in spelling, he got 12 out of 20. 20 times 5 is 100, 12 times 5 is 60, so that's 60%. So his highest mark was 90%, and he got that in reasoning. Now, in what subject did Tom get the lowest mark? Well, that's 60%, and he got that in spelling. And in which 2 subjects did he get the same marks? He got 85% in arithmetic and 85% in reading. So that's arithmetic and reading. This graph shows how the weight of a baby changed over 12 months. From the graph, what was the weight of the baby at 10 months? So we can find 10 months, draw a line up, and then draw a line across from where it hits the line on the line graph. Now we can see that that's more than 8.5, because this little line in the middle of 8 and 9 is 8.5, so it's more than 8.5, but it's less than 9. So I would estimate 8.7. You also get the mark for 8.6 or 8.8. Now, how much more did the baby weigh at 5 months than at birth? So at 5 months, we can see that the weight was exactly 7 kilograms. And at birth, we can see that it's more than 3.5, so more than 3.5, but less than 4. So I would estimate that at birth, the baby weighed 3.7 kilograms. Now the question asks how much more, so we need to find the difference. And to do that, we can subtract. So remember, 7 is the same as 7.0. So if you're subtracting a decimal from a whole number, you can put a 0.0 on the end, and then that gives us 3.3. So our answer is 3.3 kilograms. You also get the mark for 3.2 or 3.4. In a survey, people were asked if they like tea and coffee. The results are in this Venn diagram. What percentage of people in the survey like both tea and coffee? So we have a circle for tea and a circle for coffee. So the people who like both will be in the section where tea and coffee, so where our circles overlap. So that's 18 people that like both. But we need to think, how many people do we have altogether? Because a percentage is always out of 100. we have 3 plus 8, so 21, plus 9 is 30, plus 20 is 50. So there are 50 people altogether, but because a percentage is always out of 100, we need to find an equivalent fraction to 18 over 50, which has a denominator of 100. 50 times 2 is 100, and 18 times 2 is 36. So because that's equivalent to 36 hundredths, we have 36%. Now, what percentage of people in the survey do not like coffee? So that's the people outside the circle for like coffee. So we have 3 here who only like tea, but we also have 20 who don't like tea or coffee. So that's 23 altogether who do not like coffee. We have 50 people in the survey, but again, we need to find an equivalent fraction with a denominator of 100 because we need a percentage. 50 times 2 is 100, 23 times 2 is 46, so that's 46%. Here is a T-shape made from 3 identical rectangles. The area of the T-shape is 90 centimeters squared. Work out the value of x. So we need to find the value of this length here. Now we know that these 2 lengths together, the length of 2 rectangles is 12 centimeters, so that means the length of a rectangle is 6 centimeters. And our rectangles are identical, so these lengths will be 6 as well. So we know that 3 rectangles have an area of 90 centimeters squared. So we can find the area of one rectangle by dividing 90 by 3, and that gives us 30 centimeters squared. So we know that each of these rectangles are 30 centimeters squared, and to calculate the area of a rectangle, we multiply the length by the width. So we know that 6 times whatever x is must be 30, because if 3 rectangles have an area of 90, one rectangle must have an area of 30. Now 5 times 6 is 30, so that means the value of x is 5. Look at these numbers. So first we have 3/4 of a million, so that's 750,000. If you know that 3/4 of 100 is 75, that means 3/4 of a million will be 750,000. So we need to compare these numbers, and first we have what is the largest number. Well, that's 2,109,000, because if we look, we have 3 numbers with 7 digits, and they all have 2 as the millions digit. So if we look across to the 100,000s digit, this number has a 0, but both of these numbers have 1. So one of these numbers must be the largest, and to decide which, we can move across again. But both numbers have 0 as the 10,000s digit, so we need to go all the way over to our thousands digit. Here we have 1, but here we have 9. So this number here, 2,109,000, is our largest number. And our smallest number will be 80,000. And we can spot that straight away, because the number 80,000 only has 5 digits, and all of our other numbers either have 6 digits, like this one here, or 7 digits, like our other numbers. And if a number has fewer digits, and it's a whole number, not a decimal, then you know that it will be smaller. Grace, Ellie and Alfie bought 5 pizzas to share. Grace ate 1.5, Ellie ate 1 2/3, and Alfie ate the rest. How many pizzas did Alfie eat? Well, what we can do is add up the total that were eaten by Grace or Ellie and then subtract that total from 5. So we need to work out 1½ plus 1 2/3. To add fractions, we can convert mixed numbers into improper fractions. So 1 times 2 is 2, plus 1 is 3, and the denominator stays the same. 1 times 3 is 3, plus 2 is 5, and the denominator stays the same. But to add fractions, we need a common denominator. Now 6 is in both the 2 and 3 times tables, so we can find equivalent fractions with a denominator of 6. So 3/2 is the same as 9/6 and 5/3 the same as 10/6. So if we add those, that gives us 19/6. 19 divided by 6 is 3 remainder 1. So Grace and Ellie ate 3 1/6 altogether. But we want to know how many Alfie ate. So we need to work out 5 minus 3 1/6. That's 1 5/6, because 5 minus 3 is 2, and if we take 1/6 away from 2 wholes, we have 1 5/6. So our answer is 1 5/6. Now subtracting a fraction from a whole number can be confusing, but remember the whole number 5 can be written as 5 over 1, and that's equivalent to 30 over 6. 1 times 6 is 6, 5 times 6 is 30, and that makes sense because 30 divided by 6 is 5. So as an improper fraction, we know that Grace and Ellie together ate 19/6. So if we work out 30/6 minus 19/6, that gives us 11/6, and 11 divided by 6 is 1 remainder 5, so that's 1 5/6 as a mixed number. Annie ate 1/4 of a cake. 4 other children shared the remainder equally. What fraction of the cake did each of the other children get? So we know that Annie ate 1/4, which means that 3/4 was eaten by the other children. And there were 4 other children, so we can draw 4 bars below. So to find 1 bar, to find the amount eaten by each of the other children, we need to work out 3/4 divided by 4. Remember, to divide a fraction by a whole number, we keep the numerator the same and multiply the denominator by the divisor, and 4 times 4 is 16. So that means each of the other children got 3/16 of the cake. And that makes sense because 1/4 is the same as 4/16. And if we add 3/16, 3/16, 3/16, 3/16 and 4/16, that gives us a total of 16/16, and 16/16 is the same as 1 whole, and they shared 1 whole cake. In this sequence, each number is double the previous number. Write in the missing numbers. So double means times 2. So 3 times 2 is 6, 6 times 2 is 12, and so on. So to work out this number here, we need to multiply 48 by 2, and that gives us 96. Now to work out this number here, we need to find half of 3. Because if we look at the sequence in reverse, 12 divided by 2 is 6, 6 divided by 2 is 3, so we need to work out 3 divided by 2. That's 1 remainder 1, so we need to extend with a 0.0, copy up our decimal point, and write our remainder 1 in front of our 10th digit. Now 10 divided by 2 is 5, so our missing number here is 1.5. But now to find this number, we need to divide 1.5 by 2. 1 divided by 2 is 0 remainder 1. 15 divided by 2 is 7 remainder 1, so we extend with a 0. And then 10 divided by 2 is 5, so our number, half of 1.5, is 0.75.